Imagine a battery so hot it glows white, like a sun trapped in a box. A battery that doesn't use expensive rare earth minerals, but just simple carbon, which is cheaper than salt. This is one of the cheapest materials on Earth, yet it is storing energy at temperatures half as hot as the surface of the sun, waiting to turn that heat into electricity, using semiconductor chips that run silently, with no moving parts at all. Forget everything you know about lithium-ion batteries. Today, we are at the dawn of the era of carbon storage and a technology called Thermophotovoltaics, or TPV, which is breaking world records and will change how humanity uses energy forever. Why are engineers around the world so excited about these glowing bricks? It is because of the recent success from MIT and NREL, along with the startup Antora Energy, which just reached a milestone by creating TPV cells with an efficiency of over 40%. This number isn't just a new record. It marks the potential end of the steam turbine era that has dominated the world for 100 years. This is a technology that was left on the shelf 40 years ago, but today it is returning to conquer the world as the first practical solid-state heat engine for heavy industry. If you're wondering why it matters, the market for energy storage and industrial heat is worth $1 trillion, and TPV is the final key to unlocking net zero for the planet. The biggest problem with clean energy like solar and wind is its intermittency. But what if we turn that excess electricity into extreme heat and store it in thermal batteries made of graphite or carbon blocks? Antora Energy discovered that carbon is the perfect material. It costs only about $0.5 per kilogram, is abundant, and remains stable even at temperatures as high as 2400 degrees Celsius. But the even more incredible engineering secret is that the specific heat capacity of carbon actually increases as it gets hotter. This means that the hotter you make it, the more densely and efficiently it can store energy, something a standard chemical battery simply cannot do. The core of what makes modern TPV systems break through previous limits is a process called photon recycling. Think of it like this. When the thermal emitter gets hot enough to glow, it fires photons toward the photovoltaic cell. However, not every photon has enough energy to be converted into electricity. In modern TPV systems, engineers have placed a high-performance reflective mirror at the back of the cell. This mirror filters out unusable low-energy photons and reflects them back to the heat source to maintain its temperature. This process minimizes energy loss and helps push efficiency to 40%, higher than the average efficiency of steam turbines used in many power plants today. What makes TPV a true blue ocean, an untapped gold mine, is the energy economics. Many might argue that 40% efficiency is still lower than the 90% efficiency of lithium batteries, but for large-scale industry, the cost per unit of energy capacity is more important than the total round-trip efficiency. If we can store energy 10 times cheaper than lithium, even with some losses during conversion, the levelized cost of storage, or LCOS, for TPV thermal batteries still wins by a landslide. Plus, there are no issues with degradation after tens of thousands of cycles, unlike chemical batteries. This is the revolution that will transform heavy industries, longtime villains as massive carbon emitters like steel, cement, and chemical plants, into parts of a 24/7 clean energy grid. TPV technology isn't just a new kind of battery, it's the transition to a world where massive energy costs and emissions become a thing of the past. Heat that used to be waste will become power, and a simple block of carbon will become a tireless engine for electricity. If you are an engineer, this is physics turning into a multi-billion-dollar business. If you are a student, this is a golden opportunity for innovation. And if you are a parent concerned about your children's future, this is a sign that we are moving toward a cleaner world through one of the most cost-effective methods humans have ever devised.